Welcome to a quick and focused Playwright tutorial. This is a no-nonsense, high-impact crash course packed with everything you need to start contributing right away. My goal is to get you up to speed on the basics quickly, so you can start watching my other videos covering advanced test automation topics. We're aiming to turn anyone into a rock-solid Playwright expert, so grab a cup of coffee, settle in, and give me your full attention. I only need 1 hour of your time, and it's going to save you countless hours when you're tackling real-world testing. Stick with me until the end, because there will be a lot of important details in the final parts of this video, once we've built a solid foundation. Alright, let's jump right in. The official Playwright website is your best resource for all things Playwright. We'll be using it throughout this tutorial. We'll install Playwright using Node Package Manager, NPM. By the way, I'm using a MacBook in this video, but all the commands work for Windows and Linux too. The only difference is installing Node.js, but I'll cover that for all operating systems. For Windows, start by installing Fast Node Manager FNM using win-get. Next, use FNM command to install Node.js. Number 20 is the version number, which is the latest at the moment. Verify the installation by typing node_v. For macOS, I use NVM Node Version Manager, but you can also use Homebrew. The steps are straightforward. On Linux, you can use FNM, NVM, or Brew. Even though I've already installed Node.js, I'll demonstrate the process. Copy the NVM installation command into your terminal. Then, close and reopen the terminal. Type NVM install 22 for the latest version. Alright, now we're ready to install Playwright itself. During the installation, you'll be prompted with 4 questions. Just accept the default values. Once Playwright's installed, it creates a handy little environment for you. This includes a configuration file, an example test file, and a package.json file. We'll explore what each of these does later in the tutorial. Playwright has a cool code generator that can help you write your first test script in a snap. To use it, we'll run the command npx playwright codegen, followed by the test site URL saucedemo.com from Sauce Labs. This will open 2 browser windows. One has the website you're testing, and the other has the script being generated in real time based on your actions. Watch as I click into the username field and type some text. The script is tracking those actions as code. After logging in, let's add an assertion to verify we're on the right page. Click the AB button, then the products text. Playwright will pop up a dialog asking you for the text to verify, and bam, we've got an assertion added to the script. Alright, that's enough for our first test script. Let's copy this code and paste it into our example test file. We'll use the command npx playwright test and add the parameter headed so we can actually see the browser windows open during the test. The alternative, headless, would run the test in the background without opening any browsers. Playwright runs tests in Chromium, Firefox, and WebKit by default, hence 3 browser windows. Use npx playwright show report to open a browser displaying the test report, where you can see the results for each browser. Congratulations, we've successfully created our first test script. If you've followed along, give yourself a pat on the back. You're on your way to becoming a test automation specialist. But don't get too excited, there's still plenty to learn to create a real-world test automation environment. Let's dive into locating elements in Playwright. First, I'll show you how to install the Playwright extension in Visual Studio Code. Your go-to approach should always be using code generators, like the CodeGen tool or an editor extension. Your typical workflow should kick off by clicking Record a new test. This opens a browser window, and you can then type in the URL you want to test. Now you can interact with the page. Let's click on the Accepted Usernames heading as an example to get a locator for it. Not sure if clicking it serves any real purpose, but it's just for demo purposes. If you need to pause, just hit the stop button. To continue, click the Record at Cursor button, super convenient. Make extensive use of the recording features whenever possible. Even when you need to write some code yourself, start by recording up to a certain point, then add the manual steps. Alright, sometimes you'll need to write locators manually. Let's explore the built-in locators. These are your best friends for reliable tests. They have auto-waiting and retry capabilities baked in, so your code will be more robust. Here's an HTML button. You locate it using the getByRole method and provide a name as a parameter. This section might seem overwhelming at first, but don't worry. In most cases, you'll start by recording a test and then make small adjustments to the locators. As a beginner, learn how to read and modify locators. Memorization isn't necessary at this point. Here are examples for locating a heading and a checkbox. Next, the getByLabel method. It's as easy as getByRole. getByPlaceholder is just as simple. With getByText, you'd pass in the text you're looking for. All images should have an alt attribute, and you can locate them using that text with getByAltText. getByTitle locates elements by their title attribute. Surprising, I know. In many companies, elements are located by adding test ID attributes to HTML tags. That's also a very valid approach. Here's how you can customize the test ID attribute. The filter method is helpful when you have multiple elements and want to target a specific one based on criteria like text content. First, getByRole, then filter with a parameter like hasText. Then there's the index of elements. If you have multiple elements on the page, you can locate them by their order number. This isn't ideal for a test script since it's not resilient coding, but it can be useful for debugging purposes. And here's how to locate with XPath and CSS. Try to avoid these, but sometimes you can't. A quick note for experienced viewers. If you're used to the dollar method, also known as the element handle, don't use it in Playwright. It locates the element only once, and if the element changes, like after a React render, the handle points to the wrong location, causing unexpected behavior. Stick with the locator method instead. It works the same way. Alright, let's dive into how to locate an element from an HTML tag. I'll inspect the login element to see what kind of HTML tag we're dealing with. To do this in Chrome, just right-click the element and select Inspect. This will show you the element's code with all its attributes. Take a good look at those attributes. I'll copy the element and paste it into our test code as a comment, so we can reference the HTML tag while we try different locator options. Now the fun part, let's try locating the element using different attributes. The most obvious one is the ID. Simply write ID equals login button and hit run. Easy as pie. Next up, let's try the data test attribute. Same process, same result. Maybe being a test automation whiz isn't as tough as I thought. Now let's give the class attribute a shot. Oh no, that didn't quite work. The trick here is that class names need a dot in front of them, without class equals. Now how about the type attribute? Hold on, another hurdle. ID and data test work a bit differently. For other attributes, you need brackets around the value. The same goes for name and value attributes. The ID attribute can also be written with just a hashtag in front of the ID. Now let's try just input. This should work too. Nope, it didn't. Here's why. There are 3 input fields on the page, so we get a strict mode violation. In this case, you should use get-by-role and filter with has-text-login. You could do something similar with CSS, but we're trying to steer clear of that. This isn't a CSS course after all. Stick to the built-in locators, not CSS. Now that we can find elements, let's see how to interact with them. Check out the list of methods on the right-hand side. You can explore them all later, but let's break down some key ones. Clicking is a no-brainer, and we've already seen that. Then there's check for checkboxes, clear for text boxes, and count to see how many elements match your locator. Just remember, don't use count for assertions. That's what assertion syntax is for. This method is for processing information. You can double-click, drag and drop elements, and fill forms just like we did with the username and password. Focus moves the focus to a matching element. If you have iframes on the web page, you can first select the iframe and then locate an element within it. Hover is great for things like revealing tooltips. Then there's the press method for pressing a key on the keyboard. You can take a screenshot of an element to verify it looks correct. If you need to scroll to make an element visible, use Scroll into View if needed. To select options from a drop-down menu, there's a method for that too. Select Text focuses on the element and selects all the text content. For touchscreens, we have the tap method. Don't forget uncheck for checkboxes. And finally, the wait for method lets you wait until an element reaches a specific state. You can dig into these methods more when you're writing your own test scripts. They'll become second nature before you know it. Next, let's talk about grabbing values from HTML tags. This can be useful for making assertions in your tests or debugging tricky issues. I'll start by inspecting the attributes of the login button. I've copied the values earlier to the editor as a comment, so we can see them while typing. First, we need to pick a locator for the login button. Simply click the login button and the locator appears in the text box above the code. Hit Enter to copy the locator to the clipboard. Now we might try using the text content method first, since that's common for assertions. But hold on, looks like the button itself doesn't have any text content. This can be confusing for new test automation folks wondering if they messed up the locator. Don't worry, let's switch gears and try a different approach. Instead, let's target a specific attribute of the button, like the value, which should be login. The method we use is getAttribute. Boom, there you have it. You can try any attribute you like, name, type, ID, or even class. And that's it for this section on locator methods. Assertions are the backbone of verifying that elements on a page are behaving as expected. Playwright offers a wide range of assertions, and we'll focus on the most common ones. Now, I know this part might not be the most thrilling, but stick with me. Mastering these basics will save you tons of time down the road. First up, locator assertions work with those element locators we learned about. These rock because they automatically retry until the condition is met. Imagine giving an element a few extra seconds to appear before giving up. They mainly deal with basic HTML elements, like checking if a checkbox is ticked. Checking if an element is disabled comes in handy when you want to make sure a button stays inactive until a user fills out all the required fields in a form. We can also use assertions to see if an element is focused, visible on the screen, or within the viewport, meaning it's actually showing, not hidden off-screen. Counting elements in a list is easy. Say you need to know how many buttons are on a page. Just write, expect button to have count. Let's say we want to verify an element looks a certain way. Playwright lets us take screenshots of individual elements for comparison. You can assert that an element matches certain text. In addition to element-specific screenshots, you can take a screenshot of the entire page. URL checks are covered too. You can assert that a URL contains certain words like checkout, or flip it around and make sure there's no error in there, indicating you haven't landed on an error page. There's also a to be OK assertion for API testing, but that's a story for another tutorial. Let's stick to the basics for now. Now let's switch gears to generic assertions. These are non-retrying and pretty simple, the kind you'd find in most modern programming languages. They're perfect for checking values you've already grabbed from the page and stored in a variable. To be is straightforward. It checks if a value is correct. To be close to does the same for floating point numbers. We've got to be greater than and to be less than. Their functions are self-explanatory. To be truthy ensures a variable is not false, 0, null, empty, nan, or undefined. Nan stands for not a number. To contin verifies that a string contains a substring or an array contains a specific value. To equal performs a deep equality check, which is great for complex structures like arrays. It makes sure all indexes match and contain the same values. To have length checks the length of an array or string. To match ensures a string fits a regular expression. In our example, it's checking for the words is enough with a number between them. Array containing helps you find specific values within an array, and close to tackles those tricky floating point number comparisons again. That wraps up our tour of Playwright assertions, but there's more to cover. First, you can negate any assertion by adding not to it. Soft assertions are great for productivity. They don't stop the test execution but run the entire test. Consider where you can use them in your scripts to maximize efficiency. Last tip, use custom expect messages. When you're dealing with hundreds of assertions, the default messages might not always clarify why you wrote the assertion in the first place. Custom messages can really boost your debugging game. Now that we're familiar with all the assertions, let's put our new skills into practice. I'll walk you through the basic process of making assertions. We have a test that logs into our test target, and we'll add some assertions to check the page that appears after login. Using the UI, I'm going to make 3 assertions, 1 to check the product's text, and 2 to verify the visibility of the hamburger button and shopping cart. The AB button is for checking text, while the I icon button checks visibility. Here are our assertions. I'm adding custom messages to each one. It's a good habit to get into. Now if we run the test, things might seem quiet if all the assertions pass. To spice things up, let's make them all fail by adding not before each one. Now we can see the custom error message from the first assertion. Notice how the test stopped at the first assertion and didn't continue. Next, I'll make the assertions soft so we can see how the run looks then. Now the test runs to the end, and the logs show all 3 assertions. Sometimes it's helpful to see what other assertions say when one fails. The downside is that the test takes longer because it stops waiting on each assertion, but in scheduled automated runs it wouldn't matter much. Before we move on, let's peek at the Trace Viewer, a debugging superhero. Just click Show Trace Viewer and run the test again. The Trace Viewer gives you a screenshot of every test step, recreating the entire test run. Each step is shown as an image. When I click the Login button, it marks the clicked location with a red spot. You get detailed logs of what happened, including console messages. Looks like our test had some external issues we didn't create. It also shows network requests and responses. From these, we can see what caused the error in the console messages. Seems to be an API call getting an unauthorized response. We don't need to worry about that, but you can see how easy it is to debug this kind of problem with the Trace Viewer. If a web developer needs more info about an issue, you can easily zip up the trace and send it to them. They can view it using the command npx playwright show trace. Alright, Now for a coding exercise to practice those generic assertions. Remember, these are non-retrying, so you need to be sure the variable you're checking already has the value you want to verify. We'll verify the correctness of these two prices by adding them up and checking their sum. First, let's inspect the first value to see what kind of HTML tag it has. There's a data test attribute we can use for locating. There's also a list of inventory items, and we need to get the prices of the first two items. I'll define two variables, and as a good practice, I'll first make the assertion so it fails until we have the correct input values. We expect A plus B to be $39.98. Now let's write the locator based on the attribute we found. I'll add text content to get the price from the element. It failed. I wanted to show you what happens when you forget to add weighting in front of the locator. You get a weird error saying page, context, or browser has been closed. It's good to learn to recognize some of these common error messages. Here's another error message to learn from: strict mode violation. We've got multiple inventory items, but our code is trying to get only one. Let's add the index of our price item, and while we're at it, let's create the locator for the second value too. There we go. We're getting the values from the elements now, but there are dollar signs we need to remove. Also, the values are strings, so the plus sign is concatenating strings instead of adding numbers. Let's remove those dollar signs. We can do that with the substring method. Using substring1 removes the first character. Almost there. Now we need to convert those strings to numbers using the parseFloat method. And voila, our assertion finally works. Visual comparisons are a standout feature in Playwright. Truly cool and useful. Currently, no other test framework handles this as effectively. For this demo, we need a test target that changes slightly with each load. We'll use a different test target than usual. We'll capture a screenshot of the entire page and one individual element. We'll use soft assertions here, so even if they fail, the test will keep running and check both screenshots. Now we'll locate the subscribe button. Interestingly, when I tested this code earlier, the UI picked locator didn't work, so I'll check the HTML tag for location. Conveniently, they've included a data test ID attribute on the live site, which we'll use. That was straightforward. Next, we need to update the snapshots by running the test once with that parameter. Updating snapshots creates a folder with images for all browsers and screenshots. During the test, Playwright will capture new images and compare them against these saved reference images. It looks like 2 out of 3 browsers failed. Error: screenshot comparison failed. The difference is 32,000 pixels, ratio 0.04 of all image pixels. Here's the image comparison. we can see one section of the page has changed. Chromium only failed the whole page screenshot. The subscribe button was fine. Let's check the other failing browser too. Both the whole page and element screenshots failed for this one. If you need to compare slightly different images, you can use the max diff pixels parameter when taking the screenshot. Alternatively, you can define this parameter in the Playwright config file for all screenshots in the test set. See, Playwright makes visual comparisons a breeze just like everything else it does. Alright, let's explore how to configure your test environment. The Playwright config TS file is where all the magic happens. Most of the variables in there are pretty straightforward. You've got your test directory, how many times to retry tests, which reporters to use, and how many worker processes to spin up for test execution. Projects tell Playwright which browsers to use. We'll get into the nitty-gritty of cross-browser configurations a bit later. The default test config gives you a solid starting point, but if you want to explore all the configuration options, you'll need to hit up the documentation pages. Setting a base URL for your test target is very useful. This way, in your tests, you just append to that base URL when navigating between pages. The web server parameter is handy for launching your test target on your local machine. There are also parameters for filtering test files, global setup and teardown, and expect options. It's worth taking some time to check these out yourself. You might find some that fit your specific needs. Next up are the test use options. These control things like emulation, network settings, and recording options. With emulation, you can tweak things like color scheme, geolocation, locale, time zone, and viewport. Network options let you add extra HTTP headers, set up HTTP authentication, or even route your tests through a proxy. There are a bunch of other options, but I don't want to overwhelm you. One that's particularly useful, especially when debugging or dealing with flaky networks, is the slow-mo launch option. This slows down Playwright operations by a specified number of milliseconds, giving you a chance to see what's happening. You've also got user agent and viewport parameters to play with. Many of these configurations can be set via command line as well. If you type npx playwright help test, you'll get a list of command line parameters, many of which are the same as those in the configuration file. Let's talk about cross-browser testing with Playwright. In the config file, you'll find the project's parameter. By default, Playwright runs tests on Chromium, Firefox, and WebKit. But here's where it gets really cool. You can easily set up mobile devices too. Check out this example of adding a Google Pixel 5 to your test runs. While it's not a perfect mobile test, it's a solid option for web app testing using the right user agent, viewport, and browser engine. To find more devices, head to the Playwright emulation page and look for the registry of device parameters. You'll find a ton of device configs there, including all the latest iPhones. If you can't find the latest Android devices, no worries, you can easily set it up yourself. Let's give this a try. I'll adjust the layout of these lines for easy copying and pasting. I'll also add a test run for landscape mode. For this quick demo, let's pick models ranging from iPhone 6 to iPhone 15. It'll take a minute to update all the model numbers, so I'll fast forward here. And we're set. Think about how long this would take with other test automation frameworks. Now let's run these tests. I'll shrink this terminal so you can see the test browsers in action. And there you have it. In a matter of minutes, we've created and executed tests for over a dozen iPhone models. Lastly, I'll show you how to define your own phone model. Here's an example I whipped up earlier for the Samsung Galaxy S23 Ultra. All you need to do is search for the viewport and user agent online. Google or the manufacturer's docs are good places to start. Then, set the default browser type, Chromium for Android or WebKit for Apple devices. I've worked with this model before, so I know the viewport. Now, let's grab the user agent. Device Atlas usually has this info. Alternatively, you could piece the user agent together yourself if you know the model and software versions, since Samsung uses the same user agent format for all its devices. And that wraps up our cross-browser testing section. Compared to other frameworks, Playwright makes this process a breeze. Let's talk about debugging. When you hit an error in one of your tests, it's a good idea to stop other tests from running, so they don't add to the confusion. You can do this by marking the troublesome test with the test.only annotation, which makes it the only test that runs. There are other helpful annotations too. Skip to ignore a test, fix me to mark the test as failing without running it, slow to triple the test timeout for flaky tests, and fail to expect a test failure. If you need more details, check out the Playwright docs. Now let's make this real. I'll intentionally make the test fail by setting an incorrect heading text in the assertion. When running tests from the command line, you can narrow things down by specifying the test file, in this case, example.spec.ts. If the issue only happens on a specific browser, use the project parameter. Playwright automatically opens a status report when a test fails, showing you exactly what went wrong. In this case, the expected text didn't match the actual text. Sometimes you'll hit an error message that leaves you scratching your head. that's when you turn to your trusty sidekick Google. Copy that error message and search it up. Chances are, Stack Overflow's got your back with some answers or at least ideas to explore. This is where the rubber meets the road in testing. Debugging can be a grind, and you might barking up the wrong tree for a while. Don't beat yourself up. Sometimes the best move is to step away and come back with fresh eyes. Maybe sleep on it. Each hurdle you clear makes you that much sharper for the next one. Persistence is key. One option for debugging is to use the debug parameter. This opens up the Playwright inspector, where you can step through your test one line of code at a time. Here, you'll see everything that happens when a link is clicked. It waits for the locator, resolves it, waits for the link to be visible, and scrolls into view if needed. With so many things happening, you might spot what's going wrong. Let's dive into using Visual Studio Code's Playwright extension for debugging. Make sure you've got the extension installed, like the one you see on the screen. It works just like any other debugging environment. You can set breakpoints and run the test up to that point. I'll resize the editor so we can see the browser too. To start debugging, right-click on the test you want and choose Debug. The code runs up to just before the breakpoint. At this point, I can edit the line before continuing. For example, if I remove the heading name, the browser will display all the headings on the page. It looks like there are 10 headings in total. If I type a specific name into the field, the browser will filter the headings to show only those that contain that text. In this case, there are 3 headings with the word install. If I want to switch browsers, I just click the testing icon and select a different one. Firefox works just the same as Chromium. You can also set breakpoint conditions, count how many times a breakpoint is hit, or log a message when it happens. It's worth spending some time exploring these features to get comfortable with the tool. Next up, let's look at how to inspect elements using the $ method in the browser. This isn't specific to Playwright, but is useful for investigating web elements in general. Right-click the element you want to inspect, and there you'll see the header. If you type $header in the console, you can see the entire element. If you only want the text content, just add that method to the end of the line. Keep in mind, the single $sign only shows the first element it finds with that selector. Since I know there are multiple H2 subheadings, I'll use the $$ method to find them all. Click on any subheading and you'll get a peek at all its attributes. You might spot the ID or the text content attribute right there. That wraps up the debugging section. These tips should set you up pretty well. Just remember, debugging can be intense, and it's normal to feel tired, confused, and frustrated at times. But stick with it. Every issue you resolve makes you a stronger, more skilled professional. In this section, we'll explore how Playwright handles authentication and global setups. First, I'll record a test that logs in, then checks the shopping cart, a product page, and the hamburger menu. We'll throw in one assertion for each page and wrap it up with a logout. I'll create 3 simple tests. The first is a shopping cart test. The next is a product page test. The last is a hamburger menu test. Now, while it's tempting to test multiple pages and features in one go, it's not a good idea. Each page's test should be isolated, avoiding dependencies between them. Imagine the shopping cart assertion failing. The entire test would halt, preventing checks on other parts. This is just one reason to break things down. So let's split these steps into separate tests. It's also a good practice to log in before each test and log out after. This keeps the session storage, cookies, and other data fresh for each test, preventing flaky tests and making debugging simpler. I'll speed up the video here a bit, since we don't want to waste time on the trivial stuff. To log in and out for each test, we'll use the before each method to handle logging in, and the after each method for logging out. Looking good, we've got our before each, after each, and 3 tests set up. Let's run this bad boy with trace on to see it in action. It's working like a charm. Logs in, runs the test steps, then logs out. But hold up. This structure is only suitable for small test sets. For larger or more complex test suites, we need a more robust setup. I'll create 2 setups, one for global configuration and one for authentication. In real-world scenarios, you might need a global setup for all tests, some tests requiring authentication and others not. I'll create 2 files for these setups and pull the necessary content from the documentation. This global setup looks solid. I'll use it as a template for the authentication setup too. Now let's check out the authentication section in the docs. The setup script will log in and save the authenticated browser state to a file. First, we need to create a directory for this file and make sure it never ends up in version control. We don't want that sensitive info leaking to anyone outside the dev team. The file will be saved in the Playwright/.auth folder. That's why I added the folder to the .gitignore file. Then we'll define the file's path and name in the script. We'll copy the login script from our test file to the setup file. Once the setup script logs in, we'll add a line to save the browser state to a file. Looks good. Now we need to tweak the Playwright config file. We'll add both setup scripts as new projects. The global setup is for all tests, and the auth setup is only for the authenticated tests. For the Chromium project, we need to specify where we've stored the authenticated browser state. We'll also set up dependencies so the setups run before Chromium. I'll quickly do the same for Firefox and WebKit. Last step, we need to make some small changes to our tests. In the old version, the browser ran a script before each test to get to the right page. Now we're just loading the browser state, so we need to tell it where to start. Let's add the starting URL to each test. We're all set to run the tests and see how it goes. As expected, the tests don't log in before each test, but they start in a logged-in state. This eliminates unnecessary login steps, making the tests faster. In the end, we have a logout which could be handled in a tier-down script, but that's something you can experiment with. That's all you need to know about global setup and authentication. Up next, we'll examine best practices. By following these guidelines, you'll create tests that are less flaky, more reliable, and resistant to errors. Focus on testing what users see. Avoid verifying internal details like function names, data structures, or CSS classes. Your tests should interact with the application as a user would, based on the rendered output. Keep your tests independent. Give each one its own little sandbox to play in. This makes your life way easier when you're trying to figure out what went wrong. Before and after hooks are your friends for cutting down on repetition. But don't sweat it if you need to repeat a bit to keep tests easy to read. Steer clear of testing third-party sites or servers. When working with a database, make sure you control the data. Utilize Playwright's built-in locators for their auto-waiting and retry capabilities. These features help ensure elements are ready before interactions. Use chaining and filtering to zero in on specific parts of the page. Here are a couple of examples on filtering and chaining. Avoid using XPaths or CSS selectors. CSS selectors can break when the DOM changes, but if you stick with built-in locators using role and name, your tests won't be affected unless that specific element changes. Generate locators using CodeGen or an editor extension. Code generators pick unique locators prioritizing role, text, and test ID. If you pick a locator manually from a line of HTML code, you're only looking at a single HTML tag, but the editor evaluates the entire page to choose a unique locator. Use web-first assertions. Practically, remember to write await expect when making an assertion, not expect await. Avoid manual assertions like is visible to be true. Use the to be visible method instead. Harness debugging tools. Install the Visual Studio Code extension for Playwright and use it for debugging. Alternatively, use the debug parameter on the command line to open the Playwright inspector. On continuous integration environments, use the trace viewer to capture detailed test execution information. Make the most of Playwright's tools. Employ the code extension, code generator, trace viewer, UI mode, and TypeScript for an efficient workflow. Test across all browsers. Playwright's default configuration covers Chromium, Firefox, and WebKit, making cross-browser testing straightforward. Keep your dependencies up to date. Here's the command to keep your Playwright version current. Set up a CI environment and run your tests frequently. If you check out my channel, you'll find tutorials on running Playwright in all the major CI services. Opt for Linux images, they're cheaper. Enforce code quality with linting. Linting helps catch potential errors early in the development process. Parallelism and sharding can seriously speed things up. I've got tutorials for that too on my channel. Take advantage of soft assertions where possible. It's a productivity boost. They let the whole test run instead of stopping at the first failing assertion. That wraps up our best practices tour. Keep these best practices in mind and remember to check back often, as Playwright frequently updates its recommendations. That wraps up our tutorial. Now it's your turn to start creating tests. For more advanced topics and projects, explore my channel and don't hesitate to leave a comment with any questions or feedback. Thanks for watching.